So in your previous session, it was explained how to do the drafting so that we can proceed with the estimation and estimates. And as in my introduction, I have already mentioned that drafting is a important part of doing estimation using the software. Now, coming on to that side, we'll be discussing how to do estimation using Estimax. And we'll just revise through what we have gone through in the last session. Now, let me know when my screen is visible to you. Is my screen visible to you? Okay. Now, before starting with the estimation part, you will have to prepare a drawing. You'll have the artificial drawing with you, but you have to do some corrections in order to get it scanned through Estimax. First thing is that you'll have to draft everything in the appropriate layers. And for your reference, I'll share the file so that you can go through the same and learn how to do the drafting part. Now, the explanation for the same has already been taken in the previous session, so I won't be repeating it. You have to make sure that you're preparing a joinery table, and the same CAD notation has to be used in the artist drawing. And the walls have to be drafted in proper layers. As you can see here, the walls have been terminated near the joinery. So the template I'm going to share with you for working on will be based on discontinuity at the joineries. So I'll give a template and it works on the format that there is no line continued under the joinery. That portion you have to trim on your own. You can use the same drawing for as you have used for beam column layout preparation. If you don't have that backup file, you can ask for the same by giving a mail to the ID already mentioned in your WhatsApp group. The same mail ID in which you send the leave application, use it for sending a request for the assignment, and I'll share a file. Otherwise, you can use the same file which you have used for preparing the structure beam column layout initially. Okay, not the project you have used for doing the ETABS file, the initial file wherein you were preparing beam column layout. Okay, now the walls have been drafted in a layer. I have used a single layer. You can use multiple layers based on your likes. If there's any change in the material or wall thickness, if you want to highlight it separately or have a different calculation for the same or get a separate quantity, you can use a separate wall layer, a layer name or a separate layer. Here I'm preferring to use the same material for all the walls. So I'm using the same layer throughout. I have already marked the joineries over here. You can see only joineries are kept in text format. All other writings are kept as a block reference, or you can keep it as multi-line text. Most preferred way is that don't use a multi-line text anywhere in the drawing. Sometimes, not always, sometimes the multi-line text will intertwine with the scanning and cause interruption. And as a result, the joineries won't be scanned. So to prevent that, I'm putting it in a block reference. So whenever I want it, I can explode or edit it as required. And at the same time, it will not affect the scanning procedure. Okay, now a set of CAD utilities have been drafted. The explanation for the same has been given in a previous session, and I'll give a document stating each CAD utility, its name, and the purpose of each CAD utility. Now, coming to the structure drawing part, there are 4 different types of beams used over here. Outside beam or outer beam, inner beam, which is coming in within the building, and below this portion there is a wall. If there is no wall supporting the slab, where there is no wall beneath the beam, it is called a ceiling beam and it's denoted separately. And here I have another category of beams, that is outer C beam. So there are 4 categories of beams in this one. This is mainly for distinguishing the type of plastering I have to give, whether it's external plastering or internal plastering. If you are trying to give the same type of plastering for internal external walls, then you may ignore this categorization and you can focus on the depth or width of the beams. Okay, now here you can see that the outer C-beam is in polylines, which is not going to be scanned when we are running in Estimax. So better you explode it and make it into lines. Only lines will be detected in the case of beams. And similar for walls also, you have to draw them in lines instead of polylines. For CAD utilities, like the kitchen dado, kitchen finish, etc., you can use the polylines. Okay, after drafting, here you can see that I have a joinery table, the arc plan for ground floor and the headroom. Similarly, I have the plinth beam foundation layout. Then the the ground floor roof beam layout and the headroom beam layout. And you can see that the columns have been pasted in both the art drawing as well as the structure drawing. This is because in the structure drawing, the quantity of column is being calculated, whereas in the arc drawing, instead of quantity of column, it's actually used for removing the brick calculation or brick center line coming this portion. Okay. Now, either you can trim it off over here. Like in this case, I have trimmed off the wall portions from the column, or you can draft it continuously. For example, I'll just do it for here. Now, I'll off a few layers. Now, yeah, this one, and so you can see what difference it will make while scanning. Now, that is one continuous line. I can have fill it over here too, just for showing what will actually happen. You need not draft it in this pattern where there is a trimming off. You can draft in this method also. So that's fine in both ways. Like in this beam layout, I haven't trimmed off that portion from the column. I have kept it as such. You can change it or correct it while you are doing the scan. This is because we are taking the quantity calculation for column as full height instead of that is, it is a deduction from the beam quantity rather than we are terminating the height. So it will be taking the full height of the column instead of reducing the depth of the beam. We'll be taking the full height of column for calculating the quantity. That is why we're trimming off the portion within the column. Okay, now these are basic things you have to take note while doing the drafting. Once drafting is complete, you can proceed with the estimation part. Now coming into estimation side, this is the main interface of the software. And you can see that it is already connected to AutoCAD. And you can start, before starting, all keys here will be locked because we haven't started with the project. Once we start with the project, it will be activated. Now here, the drawing unit, I have used a centimeter and the same has been fixed over here. You can even change it based on your requirements. Make sure when you're changing here, you will have to add the corresponding conversion factor in the rate analysis part. Now here you can give a project name, client name, and the region. Region refers to the place where the project is located. That is mainly used in order to identify the rates of that particular region. Okay, once this is done, you can save the file. Now, this is another important thing you have to take note. We have different templates available for Estimax, and we'll be using a template in order to do the estimation. Each template will have a different rate analysis, and it will also have a different set of equations for calculating the values. And the output report will also be slightly different for each template. Okay, so you can use your template wisely in order to get the proper result. And for in your case, I'll give a template for using so that you don't have a confusion in that case. Now I'm using a template of my requirement based on the type of project and the rate analysis, and then go to open. Now all the other tools are active and can be used since we have started a file. Even when you are opening a file, these tools will be activated. Now go to saving option. Why are we saving at the beginning itself? To make sure that the CAD file and the Estimax file are stored in the same location and there is no a chance for misplacing the files. The main problem is that Estimax is taking data from AutoCAD and it will be storing it temporarily and as long as there is the same files are stored in the same place. If there is no AutoCAD file in the same folder, which is connected to the Estimax file, what happens is that the scan data will be erased automatically. So in order to prevent loss of data, we will have to save the AutoCAD drawing as well as the Estimax file in the same folder. So I have saved my AutoCAD drawing in this particular folder. I'll be saving the Estimax file also in the same folder. So keep a folder separate for each project to keep the data safe. Now, once you have saved, you can proceed with the estimation part. And the first step will be to create the parameters. Now, setting the template and using rate analysis and all, we'll fix it initially before even starting the project. Once that is done, you will have to fix and enter some parameters. Like in all softwares, even in ETABS, we had to define some materials, define some properties. Similarly, we'll have to define some properties and functions or values initially before starting the scan. Now, the first set thing we have already done initially. There is no changing or going back after this stage. Make sure that you are starting from left to right when you're working. So first file, masters, entries, tools, and final reports. And within a tab, you will have to follow this order from left to right so that you won't skip a step and you will make sure that all scanning is done properly. The simple reason is that you can't calculate the volume of a beam unless and until you are giving the width and length. So initially, first give the values. Only then go for the calculation. If you're trying to do the reverse way, you will end up getting a wrong calculation. So that is why we are telling you to use a proper pattern. You can mix up, but sometimes that mixing up might cause an internal error. And without your knowledge, the quantity will be miscalculated. To avoid that, you may use a proper procedure. Now for the masters, anyway, you can mix up within this tools, but you cannot mix up between this order. That is, you can only start with entries only after completing the masters. And for the tools part, you can mix tools and entries as you require by varying the story height or stories. Okay, now coming back to the masters part, the next part is a defaults. Now, not for all, for the template I'm going to share, you will have to fill in some default values. Not all templates require default value, but the one I'll be giving requires some default values. And I'll give an instruction for the same, how to fill in what are the values required. You can just read out what is it property and the value. Here, I'm supposing that my sunshade width as per architecture drawing is 45 centimeters. Input is in centimeter. Then pedestal height, you will have to calculate it from the structure drawing. I'm putting it as 150, which I have already calculated. Beam depth is the beam depth of foundation or the plinth beam depth. Give the value 45. You can use the same values I'm giving, or you can use the same values you have obtained after doing the ETABS analysis. Then go for the PCC thickness of 12.5, or you can even go for 10. Thread riser values, you have to refer the drawing. Now here, measure the thread. Here I have a thread of 22.86. and the width of each step is 87. Approximately go to the center length. It is almost 90 or 91.44, which is approximate, which is exactly 3 feet. So the first values, thread is 22.86. We'll calculate the rise from the total building height. Landing width, I haven't measured it, so I'll take the value. From here to here, it is almost 91.44. So it is 91.44. Staircase width is 91.44. This is the corresponding feet value. That is why, like, it is 91.44 is 3 feet. That is why I'm having decimals over here instead of round values. Now, number of steps will be defined from the drawing itself. You can count it. Simple thing you can do to count is select these lines and you get a proper count. Easy method of counting. You won't make any mistakes in this. There are 20 steps. So come back and fill here 20 steps. Now we can go back to calculating the rise of the building. Assuming that the building height is like the floor height, floor finish, one floor level to the other floor level height is 310 centimeters. Divide by 20, I'll get 15.5 as the height as each individual rise. Now take a screenshot of this so that you can use it for further filling up in the project. And you can see, you can fill the parapet height, parapet thickness, lintel depth, all according to your project. I won't be changing any of these for the time being. And even you have an option for number of residents. I'll share a sample file wherein the basic data for the project will be given. It is called a data collection sheet. Usually we give to the client to collect the basic data from them. And here you will have the floor height and all data. I'm assuming 310 for time being. You can use the same given in the data collection sheet. Okay, slab thickness is given. Excavation details are all given. Excavation detail means the depth of the footing, PCC, from the ground level. Now, if sunshade is required or not, column size, all these data can be taken from the data sheet or from your structural design sheet. And here they'll be given the house or the building as intended for how many people, how many residents. Here it is given as 4 people. We have a table for reference for the same, which we are using for all similar projects. You can either calculate it based on the IS code and find out the size of sock pit required, or you can follow the same calculation we are doing here. Now, as per my reference chart, I have the capacity for each number of people. This has been calculated based on the IS code. And here I have the length, breadth, and height values given already. So I'll be using in my default parameters. So number of residents is 4. And sock pit beam. If there is a requirements for sock pit beam, you can see from this portion. If there is no beam, the value is 0. If there is beam, you will have to enter it as 1. And in this case, there is no sock pit beam required because the size of the sock pit is not that large. Now this one is 165 and the other one is 100. Now close. No need to save, it is an automatic saving. Whenever you try to edit, it is changing based on the editing you are done. It is automatically saved. Now going back to the stories. Now, story means you are dividing the building based on the level. Up to plinth level, you are considering it as foundation. You can even change the consideration based on your requirement. You can combine both foundation and the ground floor as a single story. That is totally up to you. I'm trying to split it so that my report is less confusing. I want to get a clear picture by looking to my report. So I'm trying to divide the building in the vertical into proper floor levels. So the first level is up to plinth, and this is called the foundation level or foundation story. Then I have the ground floor and headroom. Now, the foundation story doesn't have a brick masonry. In my project, not in all projects, if there is a brick masonry between the plinth beam and the floor level, then you have to give that corresponding height over here. Here I'm using a value equivalent to 0 just to make sure that there is no brick quantity coming up. And the story height over here will be equivalent to the plinth beam. Now this is based on the consideration. I'll just show here. Foundation. Images. Now you can see that there will be brick masonry up to the plinth level. Even for your buildings, there are chances that there will be plinth beam, and above that there will be a brick masonry. We don't have a similar case over here. Yeah, similar to this one. If there is a beam, now my case is this one. There is a beam, and straight away the floor is starting above the beam. And in some cases, there will be a brick masonry in between, and then the flooring will come. So that height you will have to calculate separately, and for that calculation you will have to enter the value over here, brick height. Now for the ground floor part, you'll have to fill in the story height. I'm assuming it to be 310, and to calculate the brick height. Now why brick height is different from story height? When you take the section of a building, there is brick masonry, the lintel, and beam, slab coming in that particular section. So we'll have to reduce the depth of each member now to get the brick height, the amount of brick quantity. So considering the beam and slab, both have the same top level. Hence, we don't have to deduct both slab and beam depth, only deduct the beam depth. And when we come to the lintel portion, it is not, in this particular case, I'm not considering lintel throughout the building. Only when there is a joinery or opening, I'm considering a lintel. So I don't have to reduce it from the total story height. Instead, I can reduce it wherever there is a joinery. So I have to omit that portion. So 310 is my total building height minus the beam depth. That's all required. I'm going for a 40 deep beam. My plinth beam was 45 and this one is 40. You have to use these values from your structure design rather than assuming it. Here I'm just using assumptions in order for completing the work. Now this is 270. And just save the value. So ground floor and brick height has been done. Here lintel depth has not been deducted, which will be deducted in the later step. Then coming back to the headroom. Here headroom, I'm assuming that after the door height, I'm taking the beam depth. There is no other brick masonry coming in between. So the door will be attached to the bottom of the beam directly rather than giving a separate lintel. So the total height of building will be 250 and the brick height will be 210. Save. Yes. And close. So we have fixed the stories. We'll be changing the story similar to ETABS in the option over here in the bottom right corner. First, we'll start with the foundation, then we'll go to the ground floor and then to the headroom side. Then we have the joinery. Joinery data, you won't be adding any manual input other than entering the data in this particular table. First, delete all the data which is by default in the drawing in the file, and go to your drawing, scan the schedule you have prepared as per your drawing. Now here you have to change the joinery type. For that you can drop down and select, or just simply type D for door, W for window, and V for ventilator. It is a shortcut. And change the lintel depth. Now, lintel depth might not be the same or constant. It might be varying based on the width of the joinery. Like for Windows with great larger width, the lintel depth will be increased so as to get a proper support. So here I'm using 15 centimeter depth for all the joinery. Then save and close. Then the right analysis part, we'll discuss about this in the next session because it's a little lengthy part. Even work group and all I'll discuss in the next session. Now, you can see there are a lot of work items listed over in this particular table. How can we change or control the work display? You can do it by using the story item details. You can either access it from here or right click and take the story item details. In either way, you can do it. You can see that foundation has been added. The order here will be matching the story ID given when we are creating it. So if you're shuffling it, you'll have a shuffled order in your report as well as in this story item details page. You can select what all quantity to display and not to display. When you tick, you can get that quantity added. When you untick it, you can remove it from the report or refresh. And we'll continue with the second step. Firstly, you will have to fix all these steps. Then we'll go to the entries part. Here too, you can start in a mixed fashion, but the problem is that without defining the slab area or slab details, if you go with the arc scan, the outside and inside walls won't be automatically identified. We'll have to go and change it manually. That is the main reason why I have told that you can shuffle it, but not always shuffling will give a proper result. You can follow some procedure in shuffling. Now, in the scan or pick options, you have to follow this particular order. You can shuffle between scan and calculate, and even calculate and quantity. But within a portion, that is within these two options, go in the proper order. First, pick the footing. Here also you can shuffle. Footing and staircase, you need not follow an order. But for the scan options, follow the order of scan details, then scanner, then come to the scan structure drawing portion. Now, first scan details. Here you have two options, one to scan for the slab and other for the sunshade. And there too, we have a wide range of applications coming up. If you can recall, in AutoCAD, you had option for finding area. You can either pick the points of the polygon or the region where you want to find the area, or you can use an object which has already been drafted in a polyline. Here I have drawn a polyline to represent my slab. If it is having an equal projection, I need not draw the projection over here. Instead, I can give the projection value over here. Here in my building, I have an unequal projection, so I'm drawing it in order to make that clear that projection is not equal. Then the next thing entered is the depth of the slab as per the structure design. If it's not uniform, you will have to give separate polylines and take value. And there is another shortcut from which you can take the values easily rather than doing the drafting part. Now, if it's a slope slab, you can also find the area from the quantity from this. I'll do the demonstration for the flat one right now, and we'll do with the slope one later on. Now, reduction area means the portion where you have an opening in the slab. For example, the stairwell portion near in the stairwell is a reduction. Even in duct areas, you won't have a slab over there. So that is a reduction. In this particular drawing, this is a reduction. This one is a reduction. And even this duct is also reduction. Light well, duct, etc. is a reduction. And there won't be a slab corresponding to that in the terrace portion. Now here, I'll go for reduction no, polyline yes, and outer brick yes. Outer brick yes means that it will be identifying the outer brick quantities, or outer brick lines will be recognized from this particular step. Go for pick slab, come back to AutoCAD, pick the slab boundary, enter. Then you can go scan for the reductions, change this to yes, and you can just Select and click N for no. Change outer brick to no because you are not reducing any brick quantity or brick thickness while doing the deduction part. Brick slab, come here. You can see that the brick wall thickness has been excluded. That is why we are keeping it no in this particular scan. Now come back, brick slab, back to AutoCAD, select the light well portion, back to Estimax, back to AutoCAD. And from this, you can take all the slab area and all reductions have been picked. Now, next is the sunshade part. Now we'll keep all these side to no because you're proceeding with the sunshade. If you're having a sunshade throughout the building, you could have kept this value yes and picked the slab. So automatically the sunshade will also be picked. But I want a intermittent sunshade for each opening or joinery. So I'm going to pick it manually. Pick slab, coming back to AutoCAD, you can pick the start and end point of the joinery. Make sure that you're moving in left to right and bottom to up pattern. That is, you're moving only in clockwise direction. Now come back, pick slab, AutoCAD, points, pick points, back to AutoCAD. And here, I'll just show what happens if I'm going against the flow. If I'm picking it reverse, what happens is that the quantity will also be wrong as well as here it is wrong. Quantity is not correct and the direction. Actually, a slab has to come outside. Here what happened? It came inside. You can delete it and correct it. By coming here, delete. Then just close, refresh, come back to the scan tab and go for pick option. Back to the drawing. Bottom top order, enter. So it's picked properly. Now here you can save. There is automatic saving. Even if this error comes in, don't worry. Since this is because I have deleted a row. Close, refresh. Now that is a pattern, but we cannot do the floor scan in the foundation. So I will be deleting this portion just for a demonstration I have done. And I'll refresh. And for R scan, I'll give the demo in the next story. In this particular story where there is foundation, we'll be scanning for the structure scan. That is the plinth beam portion and the pedestal portion in the plinth beam. Then we'll go for the calculation of foundation and then we'll proceed to the next floor. Now here, change some parameters. Here you can see there is a option for entering the beam layers. You can give a list of beam layer names, which we have used in the AutoCAD file. You can type it directly in this particular window. You have to take it by using this particular option over here. Now, you will have to fill in the column layer. Column layer name will be unique. You cannot give multiple layer names. Whatever is the cross section, it will automatically consider and calculate the value. Now we'll have to give the depth and width. Now for the foundation, I am using 45 and the width is 23. Click here to make sure the change is happening. Close. Oh, I've used 40 as story height. You can change it over here or you can go back and change in the story item details. Go to scan. Select the foundation drawing. Click enter and you can wait and see that center lines have been created. Now these center line length into the width and depth will give the volume of beam. But what happens is that in these junctions, the beam and column quantities are intersecting. You will have to remove either the beam quantity or the column quantity. And as per my template, I will have to remove the beam quantity. And for that, you can either trim it in AutoCAD or better, a simple step. There are 4 corrections you can do in order to do it easily and quickly rather than trimming it off from the drawing. First, find overlap, then trim beam lines. Wait for the progress to come progress to complete to 100%. Here you can see the progress running at the bottom left corner. Once that is done, only then proceed for the next correction. You can see it has been automatically trimmed without even an effort. Okay, save, close, refresh. Now the corresponding quantities has been added. Now we'll come to the footing volume calculation. Now for the footing volume, we can use for a slope footing. You can refer your structure drawing, compare the marking over here, A, B, C, D marking with your structure drawing and enter the values. Do calculate volume. After doing the entering the values, just go execute. The volume will be calculated and save for saving the values. And for step footing, enter the footing value name as per your structure design. Number of steps, number of footing will be equal to the number of columns. And C value, as you can see, it is a pedestal height. You'll find this value by calculating from this one. Okay. The excavation depth minus the depth of each step. So from that you can find C value. Here I'm taking it as 150 from my earlier calculations. Now length as per my structure design 180, 150 and this is 30. Here I am taking a 100 offset for PCC, 200, 170 and depth of PCC is 15. The volume will be calculated, save, close. Okay. Now you can see that the pedestal quantities was only taken till this portion and my plinth beam is just above this portion. So that particular quantity is calculated as a separate entry. That is called the plinth pedestal. Plinth pedestal. Now I'll just refresh and there is changes in values. I won't be calculating the staircase volume over here. I'll be doing it in the portion of ground floor story. And the remaining thing is that I will have to scan the CAD utilities. Now, for each story, you will have to repeat entries and tools. But for masters, you don't have to repeat it for each story. You can only do it for once. Now, coming to tools, CAD utility. If you're giving a layer name, that only particular layer name will be scanned. If you're keeping it this as nil and scanning, all layer polylines or CAD utilities will be scanned automatically. You can save and close. Refresh. Now here the compound wall quantity has not been taken, so that value is 0. I'll just have this done in another session. Then we'll go with the ground floor. Just as I said earlier, we'll go with the slab details. I'll put this off. Yeah, yes. Projection, no. Yes. Outer brick, yes. Slab, come back. Usually we draft this particular lines, that polyline for slab and reduction in 0 layer. You can opt any layer other than the layers we are using for beam column and slab, beam column and other CAD utilities. Then go for the reduction part. Pick slab. Slab. Okay. Now the quantities has entered. Now this to put this back to no option. Then yes over here. Pick slab. Come back to AutoCAD. Pick the slab proper, sunshade slab. Once that is done, you can save, close and refresh. Then come back to Next step will be arc scan. Here, fix the properties. Similar to the structure scan, you'll have to give the wall layer names. Like if you're having a compound wall, a normal wall, all these can be scanned together. I prefer we don't scan the wall and compound wall in the same story because both the story height, like wall height and quantity will be merged. So I prefer to scan a compound wall in the foundation, but still I can use that name over here. So once you have written down the layer name, you need not change it for each story. You can keep it fixed and make sure that it is not being scanned in particular story. That's all. Now fill in the column layer name and also the minimum default width of wall thickness or default wall width and the maximum width. Then come back, scan layout, drawings. The drawing will open automatically because it is linked in the step where we have started the joinery scan. Now scan the portion, wait for the set lines to create. Once that is done, you'll get a notification and you can also see the progress in below here. Now go for the corrections. Before that, I'll just show why we are doing the correction. Here I have given a fillet portion. There you can see the column and brick wall quantities are intersecting. So I have to remove the portion which is inside this. If you are doing it manually for large projects, it might take a lot of time. To do it quickly, you are using the corrections over here. Find overlapping center lines, trim, then rejoin and correct junctions. Coming back, you can see the corrections have been done automatically. Now coming back to the scan tab, here you can see width, depth, length, whether it's an outside wall or an inside wall, similarly, whether it's an outside joinery or inside joinery, column details. The column details here just refers that all those portion has been removed. Doesn't calculate the quantity over here. It is only calculated in the structure scan portion. Now you can see that the joinery type, width, height, and inlet depth will be same as the one in our joinery table. Outside, inside will be as per the slab area. And brick width will be by default 23. This is the same which we are fixing while the scan, fixing in the property side. All inside walls has been drafted as 15. So I'll be changing this to 15. For all the outside walls are ticked and the inside walls are not ticked. So I'll do for the inside ones. And the outside ones are 23 thick. So I won't be changing for the same. And you can even check if it's an outside or inside by clicking Alt and that particular joinery. You have to click it over here because that's how we are representing the joinery position. Now this is an outside ventilator. If you are giving it a along the outer plaster line. This is not the outer plaster line, but the inner plaster line given over here. So I'll have to change it to keep all the layers on, otherwise scanning won't be done properly. Now check if it's outside, inside, tick and untick the portion. Then similar for walls also, check if it's outside, inside. You can easily check by clicking Alt and that particular row. Start first a cell of the row. Okay. You can even mark the number. Mark numbers in scanned object. You will get a marking in the AutoCAD file as well as in the table. You can easily access whichever marking you want. Okay, once this is done, save. And lintel reduction. Lintel reduction is done in this particular step. You will have to reduce the lintel depth in this particular portion. So lintel depth will be 270 minus lintel thickness, that is 255. Enter that value in this table in the brick height portion of the joineries over here. 255. Okay. You can check it by dropping down and the filter will be showing. If there is any other different size height given, it will be shown in this step. You close. Okay. Save. Close. And refresh. Then coming to the structure scan, same as before. Fix the properties and beam width and depth as per your design. Close this one. Go to scan tab and scan the layout. Just wait for the scanning to complete. Check if there is intersection of center lines. Yes, there is intersection. I have to remove the excess portion. Come back and do the corrections. One after the other. Only after one completing one step, go to the next one. And finally, come back to your AutoCAD drawing and check if it's corrected properly. Once that is completed, you can check all columns if they are being scanned or any column has been left out by marking the centerline numbers. You can see there is 12 columns over here. So I have all the columns were scanned properly. Just save, close, and refresh. Then footing is already calculated. No repeated calculation required. Staircase volume is required. And for this, you can use the earlier value which we have taken a snippet. Here width is 91.44. Price is 15.5. Thread is 22.86. Number of steps is 20. Slab depth as per design. And floor landing, as I've mentioned earlier, I have already added the floor landing quantity in my slab area. So I don't have to reduce it again. So that value will be put as 0, but we cannot keep the value 0. So we'll put something equivalent to 0. Then mid landing as per measurement. Height will be calculated automatically. Now go for the volume calculation. It is similar like your calculator. You have to enter the values and click calculate. Once that is done, save. Otherwise, 0 quantity will be saved. Refresh. Come to the tool side. You can see stair volume is already here. You can go for the CAD utility scan. Make sure all the layers of CAD utility are on. Then select, enter. Now, once scanning is complete, all CAD utilities will be taken into the drawing. Save, close, and refresh. Then you can see all the values have been filled automatically. There is no requirement for any manual calculations. You can come and go for the take the reports. You can change the story, repeat all this procedure for the headroom also. And in headroom part, you can see that overhead tank quantity and shuttering and all is automatically appearing. This is because when you're entering the number of residents, the calculation has been done such that automatic quantity will be obtained. But for the soak pit side, you will have to fill in some manual values so that you'll get the brick and beam quantity separately. This is because soak pit is made from brick masonry. But when size of soak pit is too large, the slab cannot stand on its own. So it has to be supported by a beam underneath. And in that design, to get both these material quantities, we will have to enter the values manually. That is how the equation has been added. For RCC tanks, the quantity is calculated based on another equation where you just have to mention the resident number of people residing in the building, and automatically the value will be calculated. Now, this is the specialty of this particular template. For another template, the calculation will be different and the approach will be completely different. Now, once you have completed the scanning part, you can go for the reports part. Now, in the reports part, you can have an abstract report, a split up detailed report, work-wise report. You can try opening all these reports and try to compare all these reports on your own. I'll just show a summary report. Now here, going for a summary report. Now the summary report is a detailed report where you have a rate analysis added. You can get this minimal report in the item short report. Material quantities, material short report is there. Parameters are added. Okay. Now similarly, we even have other reports. You can just take open the same. I'll just show the work-wise report also. Here, the work category is given the first preference. And if you check for columns or beams, you can see that for column work, the works group named column, you have quantity estimated for each floor. That is why the work is priority. So it is a work-wise report. If it's a story-wise report, the story will be the priority and work will be the subgroup. That is how it works. You can check for other reports and try it on your own. And I'll give the setup files for installing Estimax. You will have a 15 days free trial if you are registering in our website and downloading it from there. And if you are interested in working and learning Estimax and doing your assignment, you'll get an access key during the training period. Once you are an employee, you can do it free of cost, or if you are trying to do it for a commercial purpose, you can get a license from us. Okay, now this is the basic procedure we will follow for any estimations. If you have any doubts or any clarification required, you can let me know and we'll have a detailed explanation for that in the next session. Now with this, I'm winding up the current session. If you have any doubts or queries regarding the current session, you may ask now. Okay, I hope that you have started your AutoCAD drafting part. Make sure you complete it as soon as possible so that you can work with the Estimax side also. The equation creation, equation management, as well as the rate analysis, calculation and management, we'll deal with it in the next session. Okay, I guess we can wind up the session. Thank you all. Good night.